Welcome back to my YouTube channel Grandpa Mathematics. Today we'll do problems in application of integration exercise 8.1. Find the area of the region bounded by the ellipse x square by 4 plus y square by 9 is equal to 1. X square by 4 plus y square by 9 is equal to 1. This major axis is along the y-axis, minor axis along the x-axis. Let A be the area of the region y-axis and this point is 2 square, so it will be 2 comma 0, and this point B is 3 square, so it will be 0 comma 3. So this ellipse is symmetrical about the x-axis as well as about the y-axis. So we can find the area of ellipse in the first quadrant, and we can multiply by 4 to get the area of the ellipse. How to find the area? So equation of this line is x is equal to 0, and equation of this line is x is equal to 2. Equation of this line is x is 0, equation of this line is x is 2, and equation of this curve y is equal to, we have to find and we have to write, and x-axis is there. So first we have to find the equation of the curve, that we can take from here. Y square by 9 is equal to 1 minus x square by 4. So this we can write as 4 minus x square. The value of y is equal to, by taking square root on both sides, 3 by 2 square root of 4 you can write as 2 square minus x square. So the equation of curve is y is equal to 3 by 2 times square root of 2 square minus x square. So to find the area of the region, we should know A is, we will be using the formula A is equal to integral A to B y dx, where this x is A, x is B, and y is f of x and x-axis, and we can find the area of the region by using this definite integral. A will find the area of the region in the first quadrant. We have taken A is the area of the region bounded by the ellipse. Therefore A by 4 is equal to integral, this x is A, x is 0 here, so 0 to x is 2, so 2. So x varies from, x is 0 to x is 2, x varies from 0 to 2, that means dx. So y dx, that is dx means x changes from 0 to 2. So this equal to integral x is 0 to 2, what is the value of y? Y is nothing but 3 by 2 times square root of 2 square minus x square dx. Now this is equal to 3 by 2 times, this is in the standard form, integral square root of a square minus x square form, x square dx form. What is the formula is x by 2 square root of a square minus x square, so 2 square minus x square, plus a square by 2, a is 2 here, so 2 square by 2 sine inverse x by a, so x by 2, limit x changes from 0 to 2. So this equal to 3 by 2. When you put 2 for x upper limit, 2 square minus 2 square, so this term vanishes. 2 square by 2, 4 by 2, then sine inverse 2 by 2, sine inverse 1 is pi by 2 because sine 90 is 1. So into pi by 2 minus of, you put x is 0, this will become 0, this also becomes 0. So this is equal to 3 by 3 pi by 2. But what you have to find? We have to find a. So a is equal to 4 times 3 pi by 2. So this is equal to 6 pi square units. This is the answer. Here we have used the formula. We have taken this y is in terms of x and x is 0 to x is 2, and this curved x-axis we have found the area of the region using this definite integral a to b y dx. We can also find the area of this region by taking y is 0, y is 3 about the y-axis. To find the area about this y-axis, this equation of this line is y is x is what is the equation of x-axis? Y is equal to 0. Then what is the equation of this line? Y is 3, so y is equal to 3, and this y-axis and equation of this curve. When you take along the y-axis, required area a by 4 is equal to integral y varies from 0 to 3. That means dy. Okay, y varies from 0 to 3. Y varies from 0 to 3, that is dy. Dy means change in y. Y varies from 0 to 3. Then we have to find x dy. Then we have to find what is x. We have to use this equation again. Plus y square by 9 is equal to 1. Taking square root on both sides. 2 by 3 times square root of 3 square minus y square. So x is equal to x is equal to 2 by 3 times the square root of 3 square minus y square. Now we have found the equation of this curve. Y is 0, y is 3, y-axis. So now we can write the area of this region is integral y varies from 0 to 3, y is 0, y is 3, and x is 2 by 3 times square root of 3 square minus y square dy. Now you can take 2 by 3 outside. Integral square root of a square minus x square dx form, standard form. So you can write x by 2, here y is there, y by 2, square root of a square minus y square, plus a square by 2, 3 square by 2, sine inverse y by 3. Limit is 0 to 3. Now for y we'll substitute the upper limit. So 3 square minus 3 square. For y we substitute 3. 3 square minus 3 square, this term vanishes. 3 square by 2, 9 by 2. Sine inverse of 3 by 3 is 1. 3. So that means sine inverse 1 is pi by 2. Minus, when you substitute the lower limit 0, y0 means this term vanishes. Y0 means sine inverse 0. Sine inverse 0 is also equal to 0 only. So this becomes now 3 pi by 2 we have to find the value of a. Therefore a is equal to 4 times 3 pi by 2, 6 pi square root. So here we have to find the area of the region, the first quadrant, enclosed by x-axis. The line x is equal to root 3y, and the circle x square plus y square is equal to 4. Let a be the required plus y square is equal to 2 square is a circle with the center at origin and radius r is equal to 2 units. Now the line x is 3y. When you put x is 0, y is also 0 is coming. That means the line passes through origin, and we have to solve these two equations to see where this line intersects the circle. So put x is, okay, we can find the value of x. So x square, from here x is equal to root 3y. From that we can write y is equal to x by root 3. Y is equal to x by root 3. Substitute this in this circle equation. So x square plus x by root 3 whole square is equal to 4. X is equal to plus or minus root 3. So root 3 value is 1.7 something less than 2. So we can take this line is x is root 3. So this point is x is root 3, and we have to see what is the value of y. So we will substitute here. So y is x is root 3 by root 3 is equal to 1 comes. And we put minus root 3 minus 1 comes. And we are considering only the first quadrant. So you can take root 3 comma 1. So the intersection point is root 3 comma 1. can take this point as C, root 3 comma 1. The line passes through root 3 comma 1 and also origin, so we'll join these 2 points. So now we have to find the area of the region, the first quadrant enclosed by x-axis, and the line x is equal to root 3y line, this one, and the circle, so this one. So this area we have to find. So see D. So y is x by root 3 is the equation of this line. So the equation of this line is y is equal to x by root 3, and the equation of AC is that we have to find from the equation of the circle. So from 1 we get y square is equal to 2 square minus x square. This gives y is equal to 2 square minus x square under root. We call this as 2. So this is the equation of AC. So y is equal to 2 square minus x square. Now A, therefore A is equal to area of region ODCO plus area of region DACD. Now this is equal to, so to find this area, we know the equation of this line. This is x is 0, x is equal to 0. Equation of this line is x is root 3 and x-axis, and equation of this line, that is y is equal to x by root 3. So we can find the area of this region. To find the area of this region, the equation of this line is x is root 3 and equation of this line 2, x is 2, because this point is 2 comma 0. Equation of this line is x is 2, x-axis, and we know the equation of this curve, y is equal to square root of 2 square minus x square. So this is equal to integral x varies from 0 to root 3 for this region. X varies from 0 root 3. A is 0 and B is root 3. Y dx. Y is x by root 3 dx plus, to find the area of the region, x is root 3 and x is 2. X varies from root 3 to 2 and y is nothing but 2 square minus x square dx. Now this is equal to 1 by root 3 will take outside. If we integrate x, what will come? X square by 2. 0 to root 3 plus integral square root of a square minus x square dx, the standard form. So we can write x by 2 square root of 2 square minus x square plus a square by 2. So 2 square by 2 sine inverse of x by 2 root 3 to 2. A is equal to 1 by 2 root 3. For x, we'll substitute upper limit root 3. So root 3 square is 3 only will come. Minus, you put x as 0, 0 only will come. Then plus, put upper limit to 2. So 2 square minus 2 square. This term vanishes. So 2 square by 2 will get 2. Put x as 2, sin inverse 1, that is pi by 2. Minus, now put lower limit x is root 3. So root 3 by 2. Square root of 2 square minus root 3 square. 2 square minus root 3 square. Again plus 2 sin inverse root 3 by 2. So this one term up process comes. Now this is equal to 3 by 2. So this will become root 3 by 2. Then this becomes pi minus root 3 by 2, 4 minus 3, 1. Again minus 2 times sin inverse root 3 by 2. Sin 60 is root 3 by 2. So sin inverse root 3 by 2 is 60 degree. So pi by 3. Now root 3 by 2 gets cancelled. Then pi minus 2 pi by 3. Pi minus 2 pi by 3 is equal to pi by 3 square units. So this is the answer. We have to find the area of the smaller part of the circle x square plus y square is equal to a square cut off by the line x is equal to a by root 2. So x square plus y square is equal to a square is a circle with the center at origin. Radius a units. So this is a comma 0 and this point B is 0 comma a. So circle x square plus y square is equal to a square has center at origin. Now the line x is a by root 2. Equation of y-axis is x is equal to 0 and x is a by root 2. This point is radius a, this point is a comma 0. A by root 2, root 2 will be, value of root 2 is 1.414 something. So it will be less than a. So I can draw this line. X is equal to a by root 2. So you can, because x is a by root 2, a by root is less than a. So we have to find this smaller part, this circle, this line. So this is the smaller part. So we have to find the area of this region. So this x is a by root 2 and equation of this line is x is a, and what is the equation of this curve? Y is equal to what? That we have to get x square plus y square is equal to a square. So this gives y square is equal to a square minus x square, or y is equal to square root of a square minus x square. So square root of a square minus x square is the equation of this curve. So let a be the smaller part of circle x square plus y square is equal to a square. This is symmetrically about the x-axis. We can find area of ABC. This line, equation of this line is x is a by root 2. Equation of this line is x is a. And the equation of this curve is y is square root of a square minus x square about the x-axis. So we have taken this area is a, not this a. You can take this as something p. So a be the area of the smaller part of the circle cut off by the line x is a by root 2 full. So we can take a by 2. Therefore a by 2. A by 2 means area of this region is equal to integral a to b f of x dx. X is a. So this line in place of a by root is there. So a by root 2 and b that is a. So x varies from a by root 2 to x is a. What is the value of y? Y is square root of a square minus x square dx. So this equal to x by 2 into square root of a square minus x square plus a square by 2 sin inverse x by a. Limit is a by root 2 to a. 2 is equal to, now for x we will substitute the upper limit. A square minus a square, this term vanishes. A square by 2 sin inverse of a by a. Sin inverse of 1 is pi by 2 minus, now we will substitute the lower limit. X is a by root 2. A by root 2 to root 2 square root of a square minus a square by 2. X is a by root 2, x square is a square by 2. Minus plus a square by 2 sin inverse x is a by root 2. So a by root 2a. So this is nothing but pi a square by 4 minus a by 2 root 2. A square minus a square by 2 is a square by 2, that is a by root 2, minus a square by 2, this is sine inverse 1 by root 2. Sine 45 is 1 by root 2, so it will be pi by 4. Minus a square 2 into 2 4 minus pi a square by 8. So pi a square by 4 minus pi a square by 8, pi a square by 8 minus a square by 4 is a by 2. Therefore, a is equal to 2 times this. So a square by 2 into pi by 2 minus 1 square units. This is the answer. In all these cases, to find the area of this region bounded by the curve y is f of x axis, and the lines x is equal to a and x is equal to b, we will be using the definite integral a to b y dx. So to find the area of this region, we should know the equation of this line x is a, the equation of this line x is b, x-axis, and the equation of this curve y is f of x. Then the area of this region is nothing but integral a to b y dx.